Hi students, welcome back to Vijay Datta chemistry classes. This is your Purnima ma'am. So the next and very important one will be the radii of various orbits given by Bohr, right? So this calculation today I am going to derive the derivation. How did we get r equal to 0.529 into n square by z square? That how did we get the derivation? I am going to do today. Okay, let us start with the derivation. Okay, yes. Now here radii of various orbits. How to get that radii of various orbits? See, radii of various orbits. And before going to this, we should know one thing. Here it is the nucleus with the positive charge, and it has the different orbits. When electrons revolve around the nucleus in the particular orbits, they will be revolved. When it is n equal to 1, it is k shell, n equal to 2, L, M, N, O, like that it is there. So there will be the change in energy. So change in energy will be takes place over the here. When electrons are jumping from the lower energy level to higher energy level, that is the excited state. And electrons also can jump from the higher energy level to lower energy level. And here Bohr wants to calculate this radii. What is the distance from the nucleus to first orbit, nucleus to second orbit, nucleus to third orbit, nucleus to fourth orbit? So what he assumed, instead of calculating for first, second, third, if we calculate for radius of the mth orbit, then we, if you substitute n equal to 1, you will get the radius. Radius is nothing but distance from the nucleus to the shell. Which shell you are taking? If you are taking the first shell, so nucleus to the distance from the first shell, second shell, like that. So he wants to calculate the radii of the various orbits by assuming that nth orbit like. Now that radii of various orbits here we are going to take. And one more important postulate here we required for the explanation of radii of various orbits here, that is mvr equals to nh by 2 pi. That is what taken by the Bohr here. mvr equal to nh by 2 pi. M is the mass of electron, V is the velocity of electron, R is the radii of the electron, radius of the orbit actually. N is the number, Planck's quantum number, H is Planck's constant, 2 pi is he has taken as the integral multiple, like he has been considered. Okay. MVR equal to NH by 2 pi also he has taken. Now come and enter into the topic. See here, radius of vary orbit we are. So we have considered an electron which mass is m. So I have taken one electron which is rotating to the nucleus. Okay, that electron mass of this electron I am assuming as m, and the charge is E, revolving around the nucleus of charge Z into E. So it is revolving into the nucleus with the charge Z. Z is the atomic number and E is the charge. So let V be the, that is nothing but here V be the tangential force which is acting on the electron, which is the tangential velocity, like we can take tangential velocity of the revolving electron, and or the radius of the orbit, revolving electron, and or the radius is nothing but, suppose here it is a nucleus, electron is revolving, the radius of the orbit we are considering as the r. So the electrostatic force of attraction, between the nucleus and the electron, here we are considering as, so it is revolving with the Ze as the charge. E is the electron, m is the mass, it is the radius of the orbit, will be k into Z E square by r square. As Z is the atomic number, E is the charge, r is the radius. Here k is nothing but called permittivity of the medium. Okay, k is the constant, that k will be equals to 1 by 4 pi epsilon naught. Okay, epsilon naught, which is equals to, this epsilon naught is called permittivity of the medium. Epsilon is called permittivity of the medium here. epsilon naught is the permittivity of the medium and it has its equal, it is numerical value of 1 by 4 pi epsilon naught. This k value will be 9 into 10 to the power of 9 newton meter square per coulomb square charge. Here we are taking. Okay. Now come to this one. So when the electron is revolving around the nucleus, here on this electron, some tangential velocity will be, it has been taken place. So at the same time, the attraction from the nucleus, at the same time, the centrifugal force also will be worked on the electron. So this is the attraction and this is the centrifugal force, that two only making the electron revolve in the particular path. So he has considered the attraction from the nucleus and the centrifugal force, both he has taken. So if you consider whatever the attraction from the nucleus, we have that one just now we have taken as k z e square by r square, and also it has some centrifugal force of attraction, right? That centrifugal force of attraction value will be mv square by r. Okay, here see, these are if we get cancelled, then it is left with k kze square. So r get cancelled, so what is left here? K z e square by r, which is equals to mv square, right? So I want v square equal to k into z into e square by mr, but actually that k is called 1 by 4 pi epsilon naught, right? So this one 1 by 4 pi epsilon naught into z e square by mr. But actually what we know, MVR equal to, one of the postulate is NH by 2 pi, right? One of the postulate is MVR equal to NH by 2 pi. I'll change the ink color. This MVR equal to NH by 2 pi, want to substitute here. So 1 of V square will send 1 V this side. Then V equals to, otherwise see here, MVR, okay, V we can take. Otherwise MVR equal to NH by 2 pi we have. So what we want? We want. V equal to NH by 2 pi mr. Just substitute this value here. What is the relation we have here? V square equal to 1 by 4 pi epsilon naught. Otherwise, kze square by mr. Kze square by mr. In this, if you take the v square value, if you substitute the v, what is v? Nh by 2 pi mr whole square into kze square by mr. Then it will be n square h square 4 pi square m square r square equals to k z e square by mr. That is what now I whole square this one, n square h square, 2 square means 4 pi square m square r square equal to k into z e square into by mr I written. So see here, anything if it is getting cancelled, then you can cancel those. M can get cancelled, R can get cancelled, isn't it? So see here, how can we convert this one? K z e square equal to n square h square by 4 pi square m r. We want r because we are doing for the radius. So r equal to n square h square by 4 pi square m. If we bring this k z e square value here, k z e square, isn't it? M into k into z e square. So here we know already the k value 9 into 10 to the power of 9. Z is nothing but, if you are taking for the which atom, that one E is the charge of the electron, M is the mass of the electron. 4 value we know, pi value is 3.14 or 22 by 7 whole square. H square is the Planck's constant called 6.625 into 10 to the power of minus 34. If you substitute all these values into this one, so simply you will get R equal to n square into all these values. If you substitute, you will get 0 0.529, 0.529, which is according to the units of angstrom. So R equal to 0.529 into n square angstroms. If you want to take it is in the picometers, 52.9 into n square picometers. Here you have taken for ZMA actually. Then Z is, if you take it for the hydrogen Z value 1, but that Z is also important, n square by Z actually. Okay. So R equal to 0.5 R nth orbit, 0.529 into n square by Z angstroms. If they asked for the first orbit of hydrogen, then R equal to 0.529 into first orbit minus 1 square by Z value for hydrogen is 1. So R for the hydrogen is 0.529 angstroms. If they asked for the second orbit of lithium 2 plus, second orbit, what is the radius he is asking. So simply the formula Rn equal to 0.529 into n square by Z angstroms. He is asking for the second orbit, so R2 0.529 into second orbit means 2 square means 4 by Z value for the lithium atomic number is 3 angstroms. If you calculate, you will get the answer. Like that you calculate for everything. This is called radii of various orbits given by the Bohr. This is the formula is which is very very important, and you can take it is even in the picometers also. 52.9 into n square by Z picometers. Okay, thank you students. Please subscribe to my channel, and if you have any doubts, please comment. So in my next video, I'll go with the electrons nth energy of the nth orbit, velocity of the nth orbit, like that. Okay, thank you so much. This is your Punma ma'am signing off.